All right, now we're going to move on to type 1 and type 2 errors. Sample data is used to decide whether to reject the statement in the null hypothesis. Because this decision is based on incomplete sample information, there is always a possibility of making an incorrect decision. In fact, there are 4 possible outcomes for hypothesis testing. So in a jury trial, what are the null and alternative hypotheses? Okay, so this is just an example, so we're not really following up here per se. So in a jury trial, the null hypothesis is innocent. The alternative is guilty. So I'm just using this example to help you better understand type 1 and type 2 errors. So what jury decision is associated with rejecting the null hypothesis? So if we reject the null, then we're saying the jury convicts the defendant. And then what jury decision is associated with failing to reject the null hypothesis? So we don't have enough evidence for this, so then the jury finds the defendant not guilty. Notice here we're not saying he's innocent, we're just saying he's not guilty. So is the null hypothesis ever declared true? So in this example, can you ever say someone is innocent? No, we could just say that they're not guilty in a trial. So same thing for this. The null hypothesis is never declared true. So in a jury trial, what decision is equivalent to making a type 1 error? So H null, the null hypothesis, is innocent. And the alternative hypothesis is guilty. So type 1 error, the null hypothesis is true, so they're innocent, but they are declared guilty. So declaring an innocent person guilty. That's type 1 error. Type 2 error, here's type 2. So they are guilty, but we're not rejecting that. So we're declaring a guilty person not guilty in a trial. So hopefully this helps you visually understand what type 2 and type 1 errors are. Let's look at an example. The medical pharmaceutical company has just developed a new antibiotic. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience a headache as a side effect is more than 2%. The researcher conducts a hypothesis test with the following. We did this one up above. So for this one, explain what it would mean to make a type 1 error and then a type 2 error. So for the first one, type 1 error, the sample evidence leads the researcher to believe that proportion is greater than 0.02 when, in fact, the proportion of children who experience a headache is not greater than 0.02. If you're having a hard time visualizing this, you can just go back up to this table up here and then just erase the non-guilty and guilty and fill in for the null equal to 0.02 and then greater than 0.02 and do what we did for the trial. Okay, type 2 error is if the researcher does not reject the null hypothesis that the proportion of children experiencing a headache is equal to 0.02 when, in fact, the proportion of children who experience a headache is more than 0.02. Okay, we have symbols for type 1 errors and type 2 errors. For type 1 error, we've seen this one before, alpha. So alpha is associated with a type 1 error, and type 2 error is beta. So it's a B with like a tail on the end. What does a level of significance represent? So we've talked about this in our confidence intervals. So this is alpha, level of significance, and that's the probability of making a type 1 error. The choice of the level of significance depends on the consequences of making a type 1 error. If the consequences are severe, the level of significance should be small. However, if the consequences are not severe, a higher level of significance can be chosen. Why is the level of significance not always set at alpha equaling 0.01? Reducing the probability of making a type 1 error increases the probability of making a type 2 error, which is beta.